Hello, and welcome to my show. My name is Bret. Hopefully, you're watching this live on YouTube. And if you're not, we do this live every Thursday for years now. We're almost about hit episode 200. So we're going to do a big thing for that. But this is the show where we talk about DevOps and containers and where those intersect. I'm a huge container fan, if you can't tell by the name of this channel. So we talk about containers. And today we've got someone very special on, and we're going to talk about a ton of tools. So prepare yourself for all the cool things you didn't know you needed in Kubernetes. And we're Kubernetes focused today. So for those of you that are coming here asking questions about the course, in case you're here for that, we're going to do that show next week. So next Thursday's a full course episode day where we're just going to you can ask all the questions you want about Kubernetes, Docker, all the tooling, and I'll just be here answering those with hopefully helpful answers. In case you didn't know, this show is sponsored by my patron fans. So thank you so much, Patreon people. The patrons is something where you can sign up for free, actually. You can just scroll down here at the link is below, and you can just click follow. It's kind of like a weekly email. It's about who's going to be on the podcast, who's going to be on the live show, what open source did I just release, course updates, videos I just made, all that stuff. About one email a week, one, maybe two. And if you would like to buy me a coffee, I'd really appreciate that. And then you get exclusive benefits. And we do something every month where we do a Devops Hangout, essentially. We all get in the Discord server and we talk about our projects. We bring code for review, infrastructure as code for review. We just had one last week. The next one is coming up next month. And so if you join the High Fivers group, you can be a part of that and join our High Fivers calls. We had like 10 people last week, and we went through a whole bunch of topics, and it was just like a hangout, just chatting with other DevOps professionals. So come and join us. And thank you so much to patrons. You all support this show, and you're the reason we keep doing it. All right. So welcome to the show, Marc Campbell.
Hey, Bret. Happy to be here. Thanks for having me.
I'm so glad to have you here. We've been planning this for months, and in case you don't know who Marc is, he does stuff all over the internet, and you probably have listened or seen his stuff or used his stuff. He is actually the CTO and co-founder of Replicated, which I have mentioned on this show numerous times over the last year because I've actually got to use some of their tools. And in fact, we're going to go through a lot of those today. So, Marc, how did you get to Replicated? So if you're co-founder, when did this happen?
Yeah, so my co-founder and I, we had a previous startup that got acquired, and we were working, it was a large publicly traded company. This was early Docker days, think Docker 0.4, 0.6 pre-Kubernetes. And that company was looking to ship software on-prem. And this was they were taking maybe we should ship VMs, servers. How do we think about this? And we were finishing up our time there and just really realized this is a problem that Docker, in containers in general, helps solve, right? Application portability is one of the key tenets here. And we left and we spent some time thinking about it and realized let's do this. This isn't something that everybody needs to build. There's common layers here that we can actually deliver.
Yeah. Replicated didn't start out on Kubernetes, did it?
No, so we've been around for a little over 7 years, which actually predates the first release of Kubernetes. So it started on containers, Docker, and the history. We're fully Kubernetes now. That's what we do. But
right. Spoiler.
We started building. We wrote our own scheduling and orchestration system, like everybody did 7 years ago, and then we kind of went from that and we adopted Docker Swarm and early Kubernetes. And now we're all in on Kubernetes. We've, gone through several iterations of it and pretty committed there.
Yeah. And we're going to get into it a little bit, but I've at this point, I've lost count of how many open source projects you all have. Everything from a Docker linter to a troubleshooting tool to your own Kubernetes distribution and so much more. So, is this all internal? Are these all internal employees creating all of this and maintaining all of this? Seems like a lot.
Yeah, no, it is. I think, first, for security and just really table stakes, you want to ship software. You want somebody to run it inside their Kubernetes cluster in their infrastructure. These large enterprises, they need to be able to look at the source. They need to be able to run it, modify it, and understand, what's actually happening. So just kind of a tenet that we started and a principle that we started with was everything that we want somebody else to run in their Kubernetes cluster just needs to be open sourced and licensed so that they can do it. They can use it and package it in ways that we haven't even thought of yet. There's tons of benefits that we get, but like really tons of benefits that the folks running it get also.
Yeah. And having used some of this stuff, I can say that it was actually surprising that I hadn't realized I needed a lot of this stuff before. Just because it feels like what the path that you all are on is that you're helping companies take their software and give other people the ability to run it on Kubernetes while adding a whole bunch of extra things to it to make it so much easier to maintain and run in a market where we're going to use the word COTS. So for those of you on the internet, COTS, commercial off-the-shelf software. It's kind of I don't know if I feel like it's a legacy term nowadays, but it's a term we've all been using for 20, 30 years now. I don't hear it that much anymore, but how do you define COTS?
Yeah. So, right. COTS with a C, commercial off-the-shelf software. It's, often proprietary, right? Like it's not just a Helm chart of Postgres that you want to run, but you actually want to take this piece of software that's written by and managed by like a third party, ISV, a software vendor, but you don't want to run a multi-tenant version of that software. It might be that the software vendor doesn't have a multi-tenant SaaS application. It might be that you just are, your security restrictions, your network, rules don't allow you to actually send data to that multi-tenant SaaS application. So you actually want to take the entire application, bring it inside your infrastructure and run it. Traditionally, this was done kind of hard, right? Like,
right.
Install some software. Maybe eventually we went to like, I can just run some VMs and kind of go through that. But like I'm sure we're going to spend a lot of time talking about this, but like we've realized like, containers and Kubernetes make this a lot easier and more repeatable.
Yeah. In fact, that has happened to me over the years working with software vendors that they traditionally, it was like you were saying, it's a very heavy lift. They might have shipped an appliance with air quotes because at some point it became no longer a hardware appliance. I think my first hardware appliance that wasn't like storage or whatever was way back when Google would search. They had a search engine in a box, like back in 2004. I think I don't remember
one new little box thing.
Yeah. It was like painted yellow. It was pretty. It was definitely running Linux, but we couldn't see what was going on in it, and that was my first foray into the physical appliance market. But at some point, they just started shipping VM images, and now like you're saying, the world of Kubernetes, it makes sense that it doesn't need to be the OS and up. It can now just be, well, some vendors just do a chart, but you all actually provide a whole bunch of stuff around that is more than just a chart. Of course, we're talking about companies that are not just open source, right? We're talking about companies that might have closed source software, or they might use open source, but their software isn't freely available on the internet, and you have to work with sales, and you have this typical engineering workflow where there's people that are supposed to come on site and like do a project to do all the installation through the 200-page manual or PDF that describes the install process. But you're trying to get around all that, or trying to change that paradigm.
Yeah, right. Like we look at it as kind of like there's two problems here to solve. One is, even if you were shipping a VM, a lot of software vendors would have like kind of two teams. The way they were thinking about it, they wouldn't always ship one architecture, especially in a modern, stack, your cloud native microservices. You have one thing that you're shipping to your multi-tenant cloud, offering, and then you have a different team, and maybe your on-prem product that you're packaging as a VM is like a quarter out of date, but like it's a slightly different architecture. You're replacing some cloud services with different things that are running on-prem. So we really think like one architecture, ship it both to everywhere that your multi-tenant SaaS and on-prem. But then the other challenge of these like sealed VMs, like going from the appliance to the sealed VM, like you don't want enterprises have like different requirements, and like the security footprint of that is just massive. When you have to think about OS level patches, you have to think about different configuration, in Kubernetes, manifests really become this common, API that everybody can edit. So if you have policies that you as the enterprise want to apply to third-party software you're bringing in, Kubernetes is like enables that in a way that's really never been possible before.
Yeah, for sure. And anything to move software, especially old monolithic software into containers, I'm a fan of. Like, I don't think there's been an occasion where I didn't support the move to a container in that case, because I come from that sysadmin and ops background where it was our burden to get that vendor software, make it fit in our environment and with our assumptions, and they'll require a certain OS, but we don't want to run that OS. I mean, it's a back and forth thing that I've gone through countless times, and I feel like with stuff like some of the open source software that you're creating, like we're now on like the precipice where if people don't ship, I used to say if you don't ship in a container, eventually everything you ship will be in a container. And now it's like, well, if you don't make it supportable on Kubernetes and give the customer a first class experience of a Kubernetes deployment, then they'll go somewhere else, because they're going to want at some point this Helm chart or whatever that you want to provide them that really solves a lot of these problems and provides the flexibility they need to make it work in their environment.
Yeah, and they want configuration in ways that VMs didn't really offer, right? Like you might have a modern microservice distributed application that has, a couple of different databases, different queues, and you have a customer who is running it on bare metal in an air-gapped environment, so you need to provide all that as Helm charts and all those dependencies as containers. And you might have another customer who's running it in AWS, and it's honestly easier and more stable, and like they're happier running the databases in RDS, and so they want to just provide like IAM credentials or connection strings. And so like the even the shape of that deployment is going to vary from customer to customer, and Kubernetes allows the end customer to be able to configure that.
Yeah, in fact, I think it might have. Trying to remember which podcast it was on, that was describing Kubernetes as a series of limitations for developers, and I never had really considered it that, because I always looked at it as an enabler. But I think it is that I'm now starting to understand that it is that restriction, that the templates that we give them, right? This is a deployment. This is a daemon set. Like this is what a service means, and we give them all of these pieces, but it's not whatever your heart desires. It is, these are the components we're going to give you, and as long as you stay within this sort of walled garden, you might call it, we can easily deploy, maintain, and update the app. And I think when I was starting to use your all's tools, I didn't realize how hard that would be, even if you're someone who ships a Helm chart, to keep the customer up to date, help them know about new versions. How is their current version running? Does my app need to maintain its own Prometheus installed? Do I now have to support that? Like, there's just so much of it that, once I was involved with a project that was trying to ship some COTS to people, I realized there is so much to this, and you have to we were trying to get away from supporting the OS, right? And now we were like, okay, now we were thinking, well, now we don't want to maintain our own Prometheus and our own storage stuff, PVC settings, and all these different things. And we're going to rapidly go through a couple of these, and then we're going to let you, the audience, give us questions on what you have on some of these tools, because I think we have enough tools to talk about that we could fill like a 3-hour podcast, right? And we're not going to do that.
Oh, okay.
Okay. Yeah, you were up for the challenge. Well, I would have to get another cup of coffee. But so, as I understand it, and tell me if I'm wrong here. So the basis for your enterprise product is a series of open source tools that, to me, it kind of starts with curl, which is your way. Not that you have to use curl for anything, but it is your version of a Kubernetes distribution, or a Kubernetes distribution maker. How do you describe this?
Yeah, exactly. It's nuanced, right? Like we actually look at it not as a distribution, but it's like a Kubernetes distribution creator. So kind of going back one step, one of like the core tenets that we think is important here is you ship your application to enterprise software. You want to package it one time and then have all of your customers be able to run it, whether they have Kubernetes, don't have Kubernetes, various phases in the Kubernetes adoption curve. But curl with a K, of course, is it's like a Kubernetes distribution creator. You write a declarative YAML spec to define what's included. It's just like upstream Kubernetes though. Like by default, it's running kubeadm. We've recently introduced support for K3s and RKE2. Maybe you need like a FIPS compliant Kubernetes distribution. So Rancher's RKE2 works there, or K3s for like, kind of single node, no etcd type installations. But more than just Kubernetes, you can actually, like, this is designed to like give you a script that somebody can run on a bare metal or a VM, So like it can provide the CRI, the CNI, the CSI, right? So like here you have on the screen, container D is selected. So when you run the script, it's going to install container D. It's going to install Weave. You can choose a different CNI. Ingress, you can choose what to have in there, and we're constantly adding more in here too. But like Prometheus, one that you mentioned before, it really allows you to like write this one declarative spec, pin everything to versions, and then your customers don't need to have 7 or 8 or 10 different installs. They can actually just install this one script and then get single node, multi-node Kubernetes that has all the add-ons that you wanted in it.
Yeah. I love this thing because it's, like you said, it's like a distribution creator. And I often, getting a lot of students and a lot of consulting clients coming to me and talking about their experience, I tend to advocate for a distribution rather than the vanilla upstream, just because I know that if you're not running your own cloud, you probably can get away with the distribution, and that'll save you so much time. But one of the things I love with this is that it allows me to sort of broaden my scope of what that distribution's assumptions are by me picking all the different things. Maybe I just want containerd, not Docker, or maybe I don't want the full Rancher experience, but I like Longhorn as my storage, and I'm not really doing vanilla upstream, because what a lot of people, I think, that sort of in their learning evolution, they start with kubadmin because it seems like this official tool that is wonderful for everyone. Then you realize it does only one little part.
Yeah,
and
exactly.
It doesn't even install Docker or Docker or containerd for you, right? It doesn't. It's great because it's focused, but it also doesn't solve all the problems. And this is what if I talk to people and they're a fan of kubadmin, but they're looking to solve some of these other problems without, like you said, having 12 different installs, I tend to push them now towards curl, just because if that works for them, they can just take their YAML, store it somewhere in a Git repo, and this is how I've done it before. We store it in a Git repo, use it as that is a version control for our installer, and then when there's a new version of Prometheus or a new version of Kubernetes that we want to use or whatever, we just come back here, we sort of find the new versions we want to use, and we just update our YAML in it. Basically, it's like a single file in a single repo for us.
Yeah, the script, is designed to be idempotent, right? So you have the YAML, something goes out of tune, out of like drift, right? And you can actually just rerun the script and it puts it back, or like update if the script is actually different. And each of these, it's more than just even installing Docker Registry or Prometheus. You can like expand them under the show config, and there's a lot of additional like configuration and options that you can add, so you can actually configure these to work a certain way out of the box. Like Docker Registry one, but obviously some have a lot more.
Yeah, and there's tons of docs. I spent last year studying these docs for the project I was on, and there's a lot of docs there. There's a lot of good stuff. And so on top of this, you have something else called COTS with a K, not COTS with a C like we talked about earlier, because of course everything has to have K in it somewhere.
Yeah.
And how does this layer on top of any Kubernetes distribution?
Yeah. So COTS with a K, it's like instead of, COTS is commercial off-the-shelf software. COTS is Kubernetes off-the-shelf software. It's a plugin. It's like there's two parts to COTS. One is a kube control plugin that you can use to deploy an application. Think of it like Helm. We actually also support Helm in other methods of installing it. But it assumes there's going to be a Kubernetes distribution or a Kubernetes cluster running somewhere. So you could lay that down with curl, or you can just use EKS, anything like this. COTS helps you bring licensed commercial software and run it inside that Kubernetes cluster. So it's all open source. There's a piece that runs in the cluster, like an on-prem admin console. It's a really nice UI that kind of runs alongside the application to help manage and configure the lifecycle of the application. But yeah, it's really around like delivering and managing like the life cycle of the application from the client side and inside the cluster.
Right. And the one thing that I like about COTS, for me as a consultant, is that I'm always so pro Kubernetes, pro container. And if someone is not super invested in Kubernetes yet, maybe they're on their first couple of years of Kubernetes world, and they're not Kubernetes everything in their environment. Maybe they're not used to going and checking for new Helm versions of their particular apps, or somehow, being aware of issues in the cluster without a whole bunch of advanced stuff. I love, and we're just going to give people a little taste here of a demo that you have. We talked about this before the show. We weren't sure if we were going to show a demo, but um, a lot of times, at first, it was actually kind of hard for me to understand. Okay, if I'm going to install a Helm chart, why do I need this other layer around it? But as I was working with the tooling, I really started to understand that there are things like basic Prometheus metrics that I might want people to use, or understanding that they may not be kube control or kubectl super gurus, or they might not even have access to that necessarily, and they need some sort of display of at least what versions are there. Am I on the latest version? What are the things that my app I'm consuming from the vendor? What configuration options does that vendor provide, and how can I set those? There's just so much to it that it made complete sense to me that something like this should exist.
Yeah. I mean, and so like you can walk through a full UI based setup of the application. Like this app here that we're looking at was delivered, as a Helm chart actually. So the ISV, the software vendor, creates it as a Helm chart, but the end customer never runs Helm. It's really, really good in the scenario where they might not even have Kubernetes. They just want the application. To your point, like you can configure automatic updates. You can, there's a button to click on to check for updates. You don't need to go build a manual process around that. The license is there, creating entitlements. We even go through like customize, which is really, we think is the kind of the key to like that last mile deployment where anybody can add additional things. Maybe the application shipping without a security context or whatever it is that you need. So we document and show them how they can use customize to pull all of the manifests down, add their own layer of patches in, and then apply them back up to the cluster. And keeping those as separate patches means that as you continue to check for updates in new versions of the upstream app ship, your patches, because of the way customize works, your patches will still apply and you won't lose them between versions or have to rewrite them all.
Yeah. Especially working with software that you want a mere mortal to be able to deploy. Because all software that you want to run on premise that's sufficiently advanced, it's going to have something, right? It's going to need something. You need to pick the storage. You need to provide admin credentials to the database that it's going to use, or there's always something like that. And it's hard to assume that the person that's using your software is going to be a Helm expert and know how to do overrides or
right.
The one, and this is a subject for another show, but one thing that I feel like that I've really understood is the way that you all take Helm and then you wrap it in customize for sort of last mile changes. What I'd never really considered using them both together like that, and it took a little bit of me understanding them a little bit better and how they relate, but it really worked out well in the end for me, and I really I now appreciate both of them and both of them together even more. I used to be more of a customized fan than Helm because I felt like many people were going to Helm when they didn't need to, especially for internal software. But I feel like using them together in this way where, in fact, you actually have a tool, Unforked, not something that was on your list for today necessarily, or Unfork, but can you describe what this tool is? Because it's a problem that I don't think people realize they're going to have at some point when they start doing this.
Yeah. We created this, like, it's funny, you mentioned like Helm and Customize, and like, I think I have the same kind of background, and over like recent time, I've kind of like, okay, Helm is actually pretty good. It definitely solves a problem. It's like a distinct problem than what Customize solves. And so we created Unfork here. Like if you have a Helm chart that you want to use, but something's not templated in there, like the common solution for somebody to run that in their cluster is going to be to fork the chart, go add the template functions in, add the values YAML in, and then be able to deploy that version of their forked version of the Helm chart. It creates a maintenance problem though, because when the Bitnami chart or whatever the upstream chart is gets updated, your fork is out of date, and then you have these patches that are they're not like structured YAML because of the way Helm works, that you can't really merge in. And so what we actually try to do is like compare, we'll read the Helm secret, we'll try to compare the chart versus what it's actually running, find out that it's a fork, go, use Artifact Hub and a couple other sources, try to find the best upstream match, and then turn all of your customizations into the Customize with a K patches that we can just deliver to you. And then you can actually be deploying the upstream Helm chart natively, and then use Customize as the last mile configuration. So you don't have you can stop maintaining forks of Helm charts.
Yeah. And help me understand, because I think I understand actually how it works. In the background, is it rendering the Helm chart and then using customize with that rendered YAML? Is that?
Yeah, so we see the version that's running in the cluster, and so we'll actually, like, what Unfork is actually doing is it'll find the chart that renders closest to that version. Once we run Helm template, say that's probably the closest upstream that we can have, but like it's never going to be a perfect match. You forked it. There's obviously something different here, and so the one that has the closest match will take the differences that remain and leave those as customized patches. So then in the end, exactly what you just described, you can run Helm template and then kubectl or customize before deploying it to the cluster.
Yeah. And I had never needed that advanced level of functionality until I was on this particular product that we were using where we were creating Helm charts, but we wanted to be able to use these additional last mile layers without having so much templating all throughout our chart, and we had already had so much templating to the point that it was basically just a bunch of templating speak. There was very little actual YAML in the files.
It becomes hard to lint and look at. I think one of the things that we look at is like Helm. I mean, Helm is really good with the way it builds templates, and it really probably can solve 80+% of your customers' configuration needs completely. But that last mile is it keeps going on and on and on. And at the end of the day, you're going to put these like Helm 2 YAML fields all over your chart because you have no idea what somebody's going to want to add in. And so just assume if you want to ship something into end customer environments, if you want to ship to 1 or 2, like Helm's probably really good. But if you want to ship to 20, 30, 50, 100 different end customers, like they're going to have some requests that you've never even seen before.
Right. Yeah. You're going to end up with either more than one chart, which is not ideal, or you're going to end up with so much. Yeah, your values file is basically everything.
Right, exactly.
Which is a conversation that I feel like someone needs to solve that. Like we need a better way to do values files than the ones that I've seen, because 2,000 lines of values file is just it's not human consumable. Like you just don't understand what you're looking at.
Exactly.
So, all right. So I'm trying to work this into a story, because this is kind of the story of, I feel like a little bit of this is me and how I started using all these products together. So I stumble on the Unfork, and I really get excited about that. And then I go back to my setup of my custom, I got a Kubernetes deployment. It might be curl. It might be something else. I'm maybe using COTS to manage an app, or maybe I'm not. And then I stumble onto this troubleshoot app, which is a Kubernetes add-on, open source, troubleshoot.sh for those of you listening. That's the website. And how does this fit? Because this is probably one of the most common questions I get on my show about how do I troubleshoot Kubernetes? And then the next question is, how do I troubleshoot Kubernetes when I don't even have access to it? So what is this about?
Yeah, exactly. So kind of going back to the beginning, we didn't start with Kubernetes, and as we moved to Kubernetes, like things got luck. It's really powerful, but it's also really complicated. And it turns out that supporting these installations that are running behind the firewall, air-gapped environments, you don't have site access, you can't run kube control or anything like this. They're really difficult, and a lot of the problems that we see are under provisioned or configured servers. Something was running and is no longer running, and there's like this asynchronous back and forth of, hey, can you run kubectl logs? Can you describe this pod? And the troubleshooting process takes forever.
Yeah.
So we really realized, really at the end of the day, it's collect and analyze. It turns out we actually realized it's collect, redact, and analyze, because enterprises have sensitive information. But it allows you to write a declarative manifest again that says, collect all this stuff out of the cluster. I want cluster resources. I want to know what logs are running pods. Describe this. Collect CRDs, custom resources, anything like that. And then analyze them using a set series of built-in analyzers that we have that can provide either red, yellow, or green outcomes, and show you both pre-flight. So before you install an application, you've declaratively said the application needs, this secret must exist, or it must be running in this environment, or I need GPUs on one of the nodes. I don't know, whatever they are.
Yeah. I need a certain amount of RAM, and it.
And so then customer can run it, and it's all green. So now they can go ahead and do the install. That's for pre-flight checks. And then you find out, customer number 25 that you're deploying to, oh, there's a new requirement that we need to be able to add in. You add that in, and you never have that that challenge, that onboarding challenge, that deployment challenge again for the next customer, because you've added that into your pre-flight checks. So that list should grow. And the same is on the support bundle side. Really the application's all up and running, and customer. And then one day it's not up and running anymore, and you have no idea why. We're used to kubectl, and we can sit there and troubleshoot the thing, but being able to click a button, have a redacted single archive that you can then deliver to the software vendor, to the team, and then they can actually run kube control against that archive now. So they can take that archive that was extracted from the environment, and an engineer for the software vendor can run kube control, get pods. But instead of running it against a cluster endpoint, they're running it against this tar gzip endpoint. And so they're basically able to troubleshoot that cluster without direct access to the cluster, and really just kind of it simplifies the whole troubleshooting process.
I didn't actually know it did that. That's really cool.
We just added that feature in recently. So
okay, good. I was like, man, I missed something major about that. And what I think one of the things that I didn't realize at first when I started looking at the troubleshoot tool was that it's kind of like you mentioned, in this graph shows here, it's actually, I feel like, several tools that are sort of end to end solving the problem of, before I deploy this app, are the things that the app expects to have going to be where I'm going to put it? Because we can all say, well, yeah, you can put in limits, reservations, all these things into your chart, but that's a deployment time thing. That's something that your test cluster may not be the same as your production cluster, and that happens all the time, right? So I love the pre-flight stuff, and being able to, especially for more complex solutions that I'm maybe deploying internally, or even vendor software that I might have that they just give me a Helm chart, but I want to make sure that anywhere this is deployed, it meets the requirements before, and I find that out before. I love that pre-flight part, and it's almost now to the point where I'm almost spoiled, and I expect this sort of functionality about every Helm chart I deploy. Instead of me deploying and then waiting, and then it times out. I think it's a 5-minute default timeout on Helm, and it times out, and I find out that it could never finish because there was some pre-requirements that I didn't meet, and if only I had known. And it's random stuff, right? Like, oh, this thing expects, we're going to deploy a chart that's this particular ingress and requires this CRD, and whatever your heart's content kind of thing. And I really appreciate that. And this is all off, this isn't something that requires a SaaS or some third party, because I know there's lots of other troubleshooting tools out there. A lot of them are SaaS tools, or some of them are, you have to have kube control access to the cluster. And it's hard for me to even talk about that, because one usually requires money, and another, at least to get started, it's kind of hard to define a tool, especially when troubleshooting tools and pre-flight tools are not something that you can, it's a nice feature add-on, but I don't feel like it's one of those things where I can convince management that we've got to spend a bunch of money on this thing that will someday maybe be valuable. They get that for backups, but it's sometimes a challenge with troubleshooting tools. But the thing that I really like here is that I'm often advocating to people on this show that once you get to that full GitOps approach, you shouldn't have direct access to your clusters. And so the next question people ask is, well, if I don't have direct access to my clusters, how am I going to troubleshoot? How am I going to investigate things when they don't go right? And I feel like this is now one of these tools in my back pocket where I could just say, well, see if you can possibly use troubleshoot. Maybe that'll help you be able to. I love this tarball idea, because I get this tarball, download it from the cluster, and it has, like you said, all the stuff, everything I think I need. It's just a question of me looking through the files and folders to find the thing that I need. But it's a ton of stuff. It's actually quite thorough what it collects, I think.
Yeah, and you can obviously tweak it with adding labels and additional things. Like you can actually have it if your application is using a Postgres server, you can actually have it go collect some basic runtime information from RDS, things like this, and include it in there. And right, yeah, like everything that we build at Replicated, we definitely don't ever assume site access. We're really trying to help software vendors ship to their largest enterprise customers, and Generally, the reason that they want to do that is because they don't want this, the large enterprise doesn't want to send data back out. And so like, there may be conveniences and there may be ways that like in some modes, it's easier to run in a connected environment, but it definitely can support like a fully disconnected environment.
Yeah. As a consultant, I often have that scenario where my clients I don't have access to their clusters. And frankly, I don't want access to their clusters. I don't want that kind of responsibility. But then they will pull me in, have a small little startup company I work with, and I think they're out of California, and they're running on AWS, and they're just like 3 people, and they're not Kubernetes experts, but they chose EKS for whatever reason. And often they will come to me, and I think the last one was they were having a PVC problem. No, it wasn't storage. It was ingress. They were struggling between AWS's load balancers and their own setup of proxies and stuff that they were doing inside the cluster that wasn't really AWS specific. And this was before I knew about troubleshoot. So it was a bunch of screen sharing and me copying, pasting the command I want them to type because they would type it wrong. And then they would enter it. They'd copy and paste it and enter in, then get data back. And I'd say, scroll up, scroll down. I mean, it was that sort of stuff for hours. And I probably could have just said, hey, could you just download this tool and run it against the cluster and then send me the tarball? That probably would have been a way easier approach.
And even in probably less important for that customer, but like larger and larger enterprise customers, they're running sensitive data, like having it automatically redact anything that looks like a password matches like, connection strings, or even, large enterprises consider IPv4 addresses like sensitive information. So you end up having to think about how do I redact all that and still actually get a usable output back. And it's such a manual process. What you actually want to do is codify what those redactors look like so they can just, something's broken. Trust. I need the quickest path to resolution. Click a button and send this over to you. And they trust it.
Yeah. I mean, ideally they don't have to send the tarball that they need to send you through the lawyers first, right?
Yeah.
That's going to really hold up troubleshooting.
Right. And one of the things that we work on here too with troubleshoot, just to point it out, like I think what you're describing is probably the most common way that the product is used today, this project, right? Troubleshoot is just an open source project. We embed it into our tool, but there's nothing proprietary on top of what we're adding. But in addition to the collectors and defining everything to collect, you can actually write analyzers too. And you can say things like, oh, when it's on EKS and the container runtime is this, and this message shows up in the log, well, that points to this knowledge base article. We know what that problem is, or when it's running this version of Postgres. So ultimately, you can actually push that remediation for known issues all the way back down to the end customer, where instead of them getting an archive file and sending it off to you, it can just tell them, this probably is the issue, and they can actually, because you're able to codify that knowledge base back up into the product itself.
Yeah, that's a great point. I feel like I used to work in enterprise IT, and I was ran the server engineering team, and I would often go to the help desk because we would they're always the frontline supporters, right? So they're getting calls, and I would often learn about issues that we were having that we didn't really know about because they were trying to handle it down there. And this is the kind of thing where I would have loved to have given them that, right? Given them the analyze in case the customer didn't run it and see the analyze part of it, that at least the help desk people could read that information, that sort of engineering, high level engineering stuff, and then pass that information back to the customer without ever having to touch, tier 3 support or whatever. Of course, this was 15 years ago, so I can dream. Yeah. But all right, so we're now on tool 3, and we go from here to something I'm going to pick outdated next, because it's another part of this problem of how do I know, I deployed everything and it was secure when I deployed it and it was the latest when I deployed it. But how do I know what's outdated? So, by the way, amazing website.
Yeah. The team did a great job on the website here. It definitely it's on brand for a product called Outdated. So what Outdated really does is exactly what you just said, right? It looks inside the Kubernetes cluster, anything that your kube config has access to, finds pod specs that are running, and then gets the image tag and attempts to talk to the upstream OCI registry, Docker registry, wherever it's pulling the image from, and tell you if that's like the current version. Like we named it this. Think like if you've written Node.js code, there's like a npm outdated command, and it will like look through your package JSON and tell you what's outdated. Same concept here, right? Green, yellow, and red. Green being you're on the newest version. Yellow, you may be 1 or 2 versions behind. Red being more than that. And the implementation wise, like not everything is semver tagged, and even worse, somebody might use the latest tag or be like not even using immutable tags, and so you're running something called 2.1.0, but it's not the latest 2.1.0. And this attempts to actually tell you that by actually looking at the content SHA and actually like knowing which one is the most recent version that you actually should be running.
Yeah, I mean I feel like this problem really doesn't get talked about a lot, where exactly how are we as engineers running way more infrastructure than we're ever meant to run? How do we know that things are outdated without buying like, white source, or like I pick on them because I know they're expensive, but like, buy all these really expensive security tools to monitor and maintain things. And then of course that's always run by the security team. And me as an engineer, I mean, I genuinely want to keep things up to date. I just don't necessarily subscribe to all the newsletters and all the stuff for every single repo. I do have a tendency to go in now in GitHub and find the repo or even the Helm chart repo and do the little notify me on, I think you can say notify me only on releases. And so I get the nice little release announcements in my inbox, but that's not really a sophisticated way that's enabled for a team. So I feel like this is a really easy, it installs with Crew. It just runs. I can run it on my local system as long as I have access to the cluster API, and it gives me some sort of immediate results that I could probably turn this into somehow into. I'm a big GitHub Action guy this last couple of years, so GitHub Actions. I could probably turn this into a GitHub Action that then runs on a weekly basis and then spits it out to some email or Slack or something, so that everyone on the team is aware of how old our software is quickly getting.
Yeah, I mean, I think it's important to point out that we want to keep it all up to date. But the primary reason is like later versions have less CVEs in them, right? So like less vulnerabilities. And I think like there's many ways to solve this problem. Like some GitOps, you mentioned GitOps earlier, Brett. Like, I mean, some GitOps providers will just say, oh, we'll automatically update the image running in the cluster to the latest version. We'll subscribe to updates from the registry. Like kind of gets a little bit into opinion. And the reason that we wrote the tool, like I'm not a fan of that personally. I like to have a declarative reproducible manifest that says like in this repo, like I know exactly the image that's going to happen. It's not like coming from different sources, but like, this really just enables like GitOps style deployments where you actually want to know exactly what's running, and you also still want to know what's outdated for vulnerabilities.
Yeah, I think we're all deploying containers rapidly, more now than ever. We have so many containers, and all of those are aging quickly and quicker than we all really want. In fact, you and I were talking before the call about just the sheer number of CVEs this year. Multiple ones that are critical that affect everyone that's running anything container related. Like there's a lot of stuff going on, and it's really, I mean, we're already all overwhelmed. So why not use some easy tools to at least, you can do nothing, but at least you would know.
Right.
You can choose to do nothing, but I think sometimes we're all surprised we're thinking that thing is fine, and then 2 months later it's actually got all of a sudden 15 criticals, and we didn't realize it was out of date. In fact, my DockerCon talk this year was very much focused on picking base images based on the CVE count, and not always going blind Alpine, because I know a lot of people just think that Alpine solves all their problems, and it sometimes creates other problems. So I go through the very lengthy effort for like 40 minutes of trying to explain, maybe that the default Node.js image with, I'm picking on Node.js because I'm a fan, with 180,000 files in it, and it was something like 800 CVEs in one image without your software in it. Right. Just the base image. Maybe that's not the right place to start. And so I break it down. We go through making your own. We talk about distro lists and all these other things. So this stuff can get quite complex. And I feel like sometimes a tool, a tool like just finding out, am I outdated, rather than let me scan every possible container and image in my entire worldview. Sometimes that can alleviate some of the problems before you find out from security team that scanned all your servers that you now have a bunch of vulnerabilities. It's an easier way to head them off at the pass a little bit.
Exactly, right? Like a lot of software you're running, you didn't write. You didn't create those images. They're like we talked earlier, it's commercial off the shelf or it's like third party. Some of it's delivered by operators, so you can't even look at the pod spec. And so the only way to actually know what's running is by like seeing what shows up in the cluster.
Yeah. Yeah, the real world. Not the stuff that I thought I installed, but actually the stuff I really did install.
Yeah. Yeah.
All right. So I've lost count already how many we're on. By the way, ladies and gentlemen, this team pumps out 2 different podcasts. So I just want to mention, we'll mention this all again at the end, but Kubelist. So this is your podcast, right? You're co-hosting this podcast.
It is. Yep.
And this is you described this to me. You interview CNCF maintainers.
Exactly. Right. We started off with like Sandbox, Incubating, Graduated. It's really just, talk about the projects that are out there, open source projects right now.
Yeah. And then you have Enterprise Ready, which by the way, I love this idea. As soon as I saw this about a year ago, having the assessment and the podcast and just talking about the enterprise side of all this stuff. From a practitioner's point of view, I feel like it's not you're not an analyst necessarily. It's not your professional gig. You're not someone that's a news pundit. And I know one of your other team members runs this podcast, but I've listened to a couple of the episodes, and yeah, it's good.
Yeah, it's my co-founder runs it, but like exactly, like what it takes to actually like from a product perspective to deliver enterprise like grade software.
Yeah. All right, so we've got Enterprise Ready IO, we've got Kubelist.com. Those are the podcast, and then there's something else that is it's not technically off topic, but it's not necessarily ops focused. It's maybe more on the dev side. For those of you true devs listening to the show today, database schema is something that I am constantly advising people about, but I am super ignorant about the right way to do it. Like, I don't feel like I really nailed exactly how the modern cloud native app developers are really supposed to maintain their database schema in a 3 nines or 5 nines approach. Tell me about Schema Hero, because this is something I know nothing about. So I don't have to act dumb. I am dumb.
All right. Yeah, it's a project that we created internally. It's now a CNCF sandbox project. So we've contributed to the CNCF. It's not our own anymore. We still are the primary maintainers of it. And the idea is it is a declarative way to define a database schema for Postgres, Cassandra, MySQL, SQLite, anything like this. Traditional tools to manage database schemas like Liquibase, Flyaway, things like this, that aren't tightly coupled to the code, right? Like Rails and Django might have an ORM that's tightly coupled. So let's exclude that for a minute. But like I'm writing Go code. I need to actually have a database schema running. The traditional way of managing it, I have to write imperative statements like alter table, add this column, do this. And I have to like understand the syntax of the database. And I also, interestingly, have to understand the current state of the database. Like I want to add a column, so I have to know that the column exists or not. So Schema Hero, it's a Kubernetes operator. There's a couple of ways to run it, like outside just from a CLI also. But you have a YAML file. It's a Kubernetes manifest, like everything, that defines, here's exactly what I want the table to look like. I want it to have these columns, these indexes, these like defaults, these like null, not nullable attributes. And when you tell it, apply this schema or plan this schema, it talks to the database engine, gets the current schema, and extracts and builds those alter table statements based on where the current schema is. So you don't have to know the starting place, or you don't even have to understand all the DDL that's necessary to like create these complex migrations sometimes. It came, we're shipping software on-prem, and it turns out that one of the side effects of running software in enterprise environments is enterprises may make changes to the database that you didn't expect. And then that could cause the next application update to fail because you attempted to drop a column, but like that column got renamed or something along this line. And so this is like a way to declaratively say, whatever the state of the database is, schema, I want it to be this state now. And it has like change control. So it's not just go make this change. You can, and we run it that way in some environments, but like in our main production environment, we actually have it output a plan and says, I'm going to actually execute these commands, because sometimes you actually want like a developer to look at you have a table that has, 10 billion rows, and you're like, I actually want a human to look at that, like that command before we like re-index that table in production.
Right. I feel like for the a certain amount of the history of software development, that database schema management was very database server focused. Like like Microsoft SQL had their way, and Rails apps had their way, and I know that there's other projects that exist for sort of that are all trying to be sort of a generic industry-wide language and framework agnostic way to manage your database schema. What does let's say I have a Node app and I'm talking to a Postgres database. I'm just going to pick something very generic. What does this tool? Does this tool have an ideal workflow for how I do this in production? You mentioned it's a controller. What does that workflow kind of look like from an operator's perspective? If someone said, okay, we now got a new version of the chart, maybe they're using Argo, or whether they're using a chart or Customize or straight up YAML, they've got their app and they know that there's going to be a version of the database the database is going to have to change. They're going to have to add a new column, add a new table, something. What does that workflow look like when you're using something like Schema Hero?
Yeah, it's a great question. So it's really designed for that like GitOps workflow. That's one of the things that we built it for. You put the one YAML file to define each table definition right in the actual same like application, like in the same repo, right? So you have that Node application. You might have a directory called migrations. You put all of your table definitions there. When you release it or you tag it or you continuous delivery it to your SaaS environment, your GitOps, Argo or Flux, whatever it is going to apply those, and then the Schema Hero controller will pick it up and run and actually apply the change to the production database cluster. There's best practices you still have to think about, right? Like when you think about destructive database migrations, or you added a column and the code expects that column to exist, there may be a brief period of time where your GitOps controller reconciles the Node app and the schema migrations, and they don't exist at the same time. So you learn to really make sure that your code fails okay if that schema doesn't exist.
Right.
It kind of becomes a developer task to make sure you don't have to be compatible with every version of your schema, but like maybe plus minus one as you continue to go forward. Right.
Yeah, that's often one of the questions I'll ask when we're trying to figure all this out is, okay, are we schema? I don't know what the right term is, but are we schema first or are we schema after the app update? Like how in what order do we go? And
we've actually modified our pipeline in our SaaS environment that we run that uses Schema Hero to deploy the database schema first, make sure that gets approved and finished, and then deploy the application. And then we're just not running any destructive migrations until you adding a column, the code can just assume it's there and you can deploy that all as one time. If you want to delete a column, stop using it, deploy that, then delete the column and make another deploy.
Yeah. Yeah. It's like you sometimes have to end up with multiple deploys to get through the process.
Yeah.
Well, cool. So Schema Hero, you said it's focused on Kubernetes, or you said there was something like a command line tool that you could use as well.
Yeah, we built it as a Kubernetes operator, and then realized that Kubernetes operators require cluster admin privileges, and not everybody is willing to give that permission to run on-prem software. Some people want namespace-specific things. So it is a kube control plugin delivered through Crew, and you can actually operate the entire thing with Schema Hero Plan, Schema Hero Apply right from a kube control plugin. The operator just kind of makes it automatic, and you have a full GitOps pipeline though that way.
Yeah, I like it. I'm gonna try to find somebody as a guinea pig for their apps. I can implement this, just because I feel like it's rare for me to meet a team that has truly optimize the database schema plan. Like, in general, I think the devs just try to avoid adding any new schema, right? So they can not have to suffer the pain. But it's obviously unavoidable at a lot of times. So I'm always looking for that team that sort of has figured it out, and they've done it multiple times on multiple languages and multiple designs of applications, and that they've got something that's not ridiculously complicated and wrought with potential fail points or places where you can't roll back, or like, there's just so many little rough edges there that recently we ran into a scenario where it was table locking because it needed a default value or something, and the application was never letting go of the database, and we couldn't take the app down, so we were trying to figure out how to get to be able to lock it just for the chain. It was a lot of work just for one little column. and
yeah. I don't think we have Schema Hero doesn't have all that figured out, but that's actually why we put it in the CNCF as a sandbox project, because we were like, this actually, it's interesting. It solved a lot of our problems, but it's not not trying to say it's the perfect solution here, but putting it outside of just us, it's that's what the sandbox is really for. And the CNCF is experiments to see if they're actually solving real problems. And so, we'd love to get feedback on it.
Everyone else's designs aren't exactly like yours, so why not let people experiment with it? Yeah, perfect. All right, for some of you in chat who have some questions, now is the time. We're going to start wrapping this up, but we've just went through probably close to a dozen things, and I want to make sure that anyone who has questions gets those answered. So we started off talking about Replicated, the company, and some people that are interested in the product. If you have the need to deploy your software on someone else's environments, this is probably something you should look at. And also, if you consume other people's software, especially that you're paying for, and they're not using Replicated, you might want to recommend they do so, because there's just so many parts of it that, in my own experience with complicated enterprise software, that it really smoothed it out on both the vendor side and on the consumer side, adopting it, because I was doing both. I really felt like it was filling some of the big gaps. So check that out. We also talked about curl and COTS. So curl being a distribution creator. Is there anyone? I don't know. Is there any other tool like this out there? I don't actually.
I haven't seen anybody else call their product a distribution creator yet. So
yeah. Okay. Yeah. I'm not. I haven't tried all. I know there's probably 100 ways now to deploy Kubernetes, but I haven't seen anything else like this, or that it is. Just the fact that we have this nice little curl with a C command to deploy curl with a K. It's a super easy way. I'm actually very looking forward to. I'm going to put a vote in, by the way, for the K3S, just because it's so fast to deploy, and I'm hoping that it would really cut down the deployment time of any Kubernetes cluster, just because a traditional one, there's so much to do. Anyway, I was excited when you guys added that. So
yeah, that's good. I'll pass that along.
plus one on that. Yeah, whenever I click on it, and I want to, because I now weeks ago, maybe months ago on this channel, I was declaring K3D like the way that you should always be testing everything with Kubernetes, and doing at least some basic smoke testing with whether your deployments were ready, right, and your health checks worked and your probes worked. And it's just so easy now to set up a GitHub action on your repo, whether it's the app repo or it's your curl repo, or your COTS repo, or your YAML repo for Kubernetes. I'm using all the wrong terms. For Helm or Customize, I want to know if those Helm charts work with the app before I manually test it on servers. And K3D in GitHub Actions, which is using K3S. The reason I'm mentioning this is because K3S is inside of K3D. It deploys a full Kubernetes single node cluster in 23 seconds. So it's insane, versus 10 minutes for something else.
Right.
And then we have COTS on top of that. We mentioned that, allowing you to package and easier maintain enterprise software. Is this something where, have you seen teams adopt it, very large teams adopt it for using in their own company for pushing their software maybe out of an internal team to other teams to run. Is that a use case here?
Yeah, that is a use case that fits. Really, like the product fits when like the team delivering the software is not the team consuming and running the software. And if that is like large enterprises often have like a common services team, and they'll deliver parts of the components that like the other team has to be able to run. We don't really target like first party software, but like for some organizations, some amount of first party software really does fit the description of the way that third party software is delivered and consumed, and like that, like the one that you just described.
Yeah, a scenario that I was thinking about for this was actually years ago, back when Kubernetes was relatively young. We were comparing Kubernetes to Docker Enterprise when it was in beta. That's how long ago this was. It's like 2015, 2016. And I was working with a big 5 accounting firm, and that's exactly the structure they had. They had a central IT shop that essentially was setting the standards for the rest of their data centers around the world, and were creating software that needed to be run by those teams. And they didn't have a very consistent way of. They were sort of bridging that. They were starting to bridge the gap of going to containers. So they didn't have this way in containers of setting up the standards for how everyone consumes their software. And I can imagine something like this helping them a lot with the rough edges, like using the troubleshoot and using the pre-check, the prereq checks and all that stuff. So all of these URLs for all this stuff is in the show notes below. I think almost everything is listed down there. We do have a couple of questions. Biker says 2 replicated questions. But I think he's still writing his questions. John, by the way, John in chat says he needs to talk to these people. So over here you can see our Twitter handles. So I'm just volunteering Mark's Twitter handle over there. Obviously they have a contact page on their website, but he's here a glutton for punishment. So I'm just going to volunteer his Twitter handle as a way if you want to reach out. There's probably more official ways to do that, but.
Yeah, like all the ways you said. Also, a lot of these projects actually have Slack channels also in the Kubernetes Slack. So if folks are there, like, I know Schema Hero does, Curl does, Troubleshoot does, and we're happy to obviously talk there too.
Yeah. All right, Biker, you only got a minute or 2 left before you lose out on your questions. All right, so where else can we go? So you're on Twitter. Replicated is on Twitter. I did not put that in there, but that's what, twitter.com/replicatedhq. Yep,
exactly.
Replicated HQ. Nope, that doesn't exist. I got to spell it right.
That's just, yeah.
This is live on the internet. Just searching the internet. That's, okay. I'm struggling. Oh, stop you.
Get the pop-up.
There we go. Got to spell it right. So Replicated HQ on Twitter, and I'm guessing that a lot of these have their own Twitter account, some of their socials, depending on what tool they are. So, and there's probably other ones that I didn't mention. So definitely check out on their website. Go through some of the pages because there's probably tools there that I didn't mention. All right, I'm going to give up on Biker. Sorry, Biker. I can't wait anymore for your questions. I'm tired. I'm ready to go. Biker's a regular, so I tease him. He's here every week, reliably, as well as Conrad. All right, Conrad gets the last question here. What's the process for building and deploying a tool at Replicated? At Replicated? Like internal, like people inside of Replicated building a tool? Not sure if that's what Conrad's asking. Let's assume that's what Conrad is asking.
Yeah.
So is it Mark thinks up an idea and then sends people to go work on it?
Yeah, I mean, I think up ideas, but like I don't think that I like often get the like that's not the way that prioritization works. No, the process for building and deploying a tool, on the engineering side, for others. So is this like we're talking more about like a software vendor who wants to deliver a piece of software using Replicated to their end customers? Then
let's go with that. Let's go with that.
So like it just has to be a Kubernetes application. They'll sign up for a Replicated account. It can be an operator. It can be Kubernetes manifest. It can be a Helm chart. Interestingly, a lot of customers end up using a combination of that. And then that's like our SaaS service. That's our proprietary like product that we're offering, our commercial offering. Everything that you then distribute, like, is just all the open source projects that we talked about, COTS and curl, are like open source things that you deliver as part of your application to the enterprise customers. And we handle like licensing and troubleshooting and, in all of that. But as long as you're writing a Kubernetes application, you deliver a Kubernetes application, we help get it delivered into your enterprise customers, air gap, non-air gap, Helm, like without Kubernetes, any of those scenarios.
Nice. Well, Comrade, hopefully that answers your question. All right, so we've gone through the gambit. If people have stayed long enough, they've survived the amazing list of tools that I think you all are maintaining. So now at this point, it's what's next? Any
well, I think
hot
that's a
takes?
question. Yeah, I mean, we're right now we're pretty focused around Helm. How do we make Helm charts? We're seeing, honestly, like more and more enterprise customers have adopted. They're getting like more advanced in their Kubernetes like process, right? Like they don't just want an application that's Kubernetes. They're like, no, we need an application that fits this CI/CD workflow. It needs to meet the way that we actually want to receive software. And so we're just really making sure that our workflows are compatible with that. And like, I mean, honestly, the whole ecosystem is just moving so fast that like 2 years ago, Helm existed as a package manager, but now Helm is like a preferred way to do it. And who knows what's going to happen, but like, just staying on top of it and making sure that we're compatible with the way that enterprises actually want to like receive software.
Yeah. The internals of using Helm at scale. I'm going to use that word. I hate saying at scale. I'm going to make a T-shirt that says, if you say at scale one more time, something like that. Because there's so many people that never have to worry about that. But the bigger the project for using Helm, the more you have to really dive into the internals of it. And it gets really complicated, I feel like, really fast. Like most of my work with Helm up until this last year was all just consuming Helm projects, Helm charts, and never had to fork, never had to write my own that was more than just a few containers. And I think I learned a lot this last year about the edge cases of Helm, all the little nuances of Helm, things like the default timeout, hooks that don't work the way you expect, subcharting, charts of charts, all these things that I think are, enterprise people deal with every day. And I feel for them now that I know some of these pains, because it seems all wonderful at the beginning when you start using it and you're just like, Helm install. Mm-hmm. And then at some point it's too much.
And you get Helm and OCI repos now too, which actually just opens the door to all kinds of like new possibilities.
Yeah. Conrad's asking, do you have any other tools in the pipeline? So we kind of answer that, but yeah. All right, people, you've got a job to do. You got to go try all these tools out. Thanks, Marc, so much for being here. I really appreciate your time. CTO, co-founder, Replicated, hanging out for an hour, just breaking down all the tools. I appreciate it. Thank you.
Thanks for having me. It was fun.
Yeah. All right. And next week, sadly, Marc's not going to be back to talk about more tools, but next week is course Q&A. So for those of you that are in my courses, you show up. We do this once a month on Thursdays. Once a month, you can come and ask all the questions about the courses, and I just try to answer them live. After that, we've got Aqua Security coming up in July with Anais. She's going to talk about Trivy, one of my favorite tools, all these other things from Aqua Security. We've got people coming from VMware. We've got Slim AI is going to be here in July, which is all about slim and secure Docker images. Of course, that's one of my jams. That's one of my favorite things to talk about. So that's going to be a great one, and more. So please come back on Thursdays. And if not, you can catch this obviously on YouTube. And then the podcast comes out on Fridays. This podcast will probably come out in a month or so. And you can listen to that just in any podcast player. Just search DevOps and Docker Talk. All right, everyone. We'll see you next time.